Hello everyone, my name is Kevin, and today I'm going to talk about how aerodynamics in cars and F1 racing works. So let's start with how does a car move through air? This is a definition of the aerodynamics. Aerodynamics is a motion of air when affected by a solid object. When it comes to car, it explains how air flows under and around the vehicle when it's in motion. That's why some engineers create car load shape to reduce air resistance, increase stability, and improve fuel efficiency. There are three types of things we're using for the aerodynamics, which is drag, downforce, and lift. Let's start with drag. As you can see this picture, as the car moves, it creates high pressure at the front and low pressure at the end. This pressure difference is called pressure drag or foam drag, a major force resisting the vehicle's motion. The faster the vehicle goes, the better the drag becomes. There are two types of drag. Foam drag, it happens because of car shape. As you can see, the truck is having a large shape. Meanwhile, the car on the left side has low shape, reducing drag. Skin friction is caused by air rubbing against the car surface. Some car creators create line shape to reduce drag. That's why some cars have sloping roofs, smooth curves, and low profiles to reduce air resistance, which leads us to this formula of drag. The more velocity and reference area, the less drag, and the less velocity and reference area, the more drag. To this comparison, like I said, because the truck has a large reference area, it's going slow, but the car is going faster it's because having a less reference area. Downforce is an aerodynamic force acting on the car. As the car moves, flying through the air, pushes the car toward the ground. The more aerodynamic forces, the more downforce increase. Now, let's take a look at this example of a track, and you see this F1 car goes normally. If you apply too much downforce, you're going understeer. But if there's no downforce, you're going oversteer, you could lift off the ground and lose the whole race. Lift is the opposite of a downforce, refers to the vertical force exerted on an object as it moves through air. When a car goes, it becomes turbulent and can be forced to speed up in certain areas. Top, or can be called a curve shape, has to travel slightly further distance than a car flowing straight underneath. So how can a car design the car shape for better aerodynamics? A slope rib around the front end helps air move smoothly over the car, reducing drag. A slope rib prevents turbulent air from creating an air pocket that slows the car down. When testing a car aerodynamics, they use wind tunnel. A wind tunnel simulates real-world driving conditions by blowing air over a car model, while sensors and smoke trails reveal how air flows. They help manufacturers refine designs, validate computer situations, and optimize performance, particularly for noise reduction and fuel efficiency. Spoilers, they work by directing the air upwards by directing air on the roof and the rear of car, which create lift, making the car lighter and then less stable. By directing the air upwards, they create downward force, increasing traction on the rear wheels. Diffusers, a rear under tray shape, gradually a bigger space at the back of the car. Their function is to smoothly accelerate the high velocity airflow from underneath the car, gradually expanding the ambient air pressure from the rear. How about spoilers from F1? Take a look at the front. They include cascades and end plates. They used to direct the airflow around the tires and underneath the car. Rear wings is a high pressure above the wing than below it, which push down a car. To this conclusion, aerodynamics is one of the crucial aspects. It affects from speed, stability, to fuel efficiency, and noise reduction. Whenever it's a high-performance sports car, an energy-efficient electric car, or family sedan, every car on the road is shaped by the invisible forces of air. That's all. Thank you for listening.